Hi folks, so I just want to go over some functional groups with you really quickly, just so that you have my take on functional groups. The first slide here, this is something that I think you're already comfortable with, just the idea of replacing an "-ane" or "-ine" or "-ine" suffix with a "-yl" version of that. So if you have a straight alkyl chain, you just use the prefix an "-il", so here we have hexane to hexyl. If we have an alkene, you still keep the "-ene" part, but you add an "-il" at the end. So hexenyl, it's an hexenyl piece instead of a hexene molecule. And here we have hexyne. When it's a part of something else, it's a hexynyl group. Okay, pretty straightforward, but just wanted to go over it briefly. So here's a slide that I put together. You've seen this before. It sounds like all of you are very comfortable with the methyl to decyl progression of alkyl chain lengths. Of course, the methyl to hexyl are really going to be the most common ones, but you should know heptyl, octyl, nonyl, and decyl. Carbonyls are where a lot of people start getting lost. All right, so this is very important. I've just shown you here two different versions of a carbonyl, one with the carbon explicitly shown, one with the carbon just, implied at the joint of the carbon-oxygen double bond. This slide is from my wine class, where they really struggle with identifying carbons. I don't think you'll have a problem with it, but never hurts to emphasize this. Okay, so carbonyls are a part of many different functional groups. Okay, carbonyls are not part of a functional group in and of themselves. Okay, so here we have R and R prime, two different substituents on our carbonyl carbon, and whatever those substituents are determines what the functional group actually is. Okay, so this is a Venn diagram of OH containing functional groups and carbonyl containing functional groups. Okay, the red circle highlights OH containing functional groups. Note that I said OH containing functional groups. I did not say alcohol containing functional groups. Okay, there are two kinds of OH containing functional groups. One of them are alcohols. Okay, so this is when you have an OH in which the oxygen is bound to a carbon that is not a carbonyl carbon. Okay, here we have phenol or phenyl alcohol. Okay, you'll note that the OH group, the oxygen, is attached to a carbon. It does have a double bond, so it's sp2 hybridized, but that double bond goes to carbon, not oxygen. Okay, so this is an alcohol. And here we have these OH groups attached to sp3 hybridized carbons, so obviously they're not a carbonyl. All right, so these are alkyl alcohols and phenyl alcohols, or aryl group is another word for an aromatic ring, like phenyl ring. Okay, so aryl alcohols, still alcohols. Okay, on the right here we have in our blue circle we have carbonyl containing functional groups. All right, so we all have our carbonyl in these functional groups. Okay, but again, the carbonyl is just a piece of said functional group. All right, so what matters, what differentiates one of these from the other, is what is attached to the carbonyl carbon. Okay, so in the ketone we have carbon here, carbon here. Okay, so you have a carbon on each side of the carbonyl carbon. This is a ketone. All right, in aldehydes, esters, and amides, and even carboxylic acids, this R group is going to be a carbon as well. Okay, so the difference is what is on the other side of the carbonyl carbon besides this carbon that's highlighted in orange. Okay, when it's an H, it's an aldehyde. Okay, when it's an oxygen attached to another carbon, this is an ester. Okay, and when it's a nitrogen, this is an amide. Okay, when the nitrogen is attached to the carbonyl carbon, this is an amide. Okay? So, we still have to talk about carboxylic acids. All right? So, the carboxylic acid is, again, we have, sorry, I'm messing with my colors here. We have that carbon on one side, that's what that R group is, all right? And we have an OH group on the other side, okay? OH group. So again, it's not an alcohol group, it is an OH group, and because that oxygen of the OH group is attached to a carbonyl carbon, this is a carboxylic acid. All right, so hopefully that makes sense. It is absolutely essential that you know the difference between an acid and an alcohol. Okay? Okay, so here we have a very similar Venn diagram where we take the yellow circle, which contains NH or NH2 groups, and combine them with the blue circle, which is, again, carbonyl containing functional groups. Okay? So again, I said NH2 or NH groups. All right? These, when they are attached to carbons that are not carbonyl carbons, these are called amines. Okay? You'll see here I've highlighted sort of the nitrogen version of phenol. These are called anilines. All right? This is a common name. You don't necessarily need to memorize it, but it couldn't hurt. All you need to do is be able to recognize that this is an amine group on a phenyl ring, right? It is not an amide, it is an amine, right? And the rest of these nitrogens are attached to sp3 hybridized carbons. Okay, you'll note that nitrogen makes 3 bonds where oxygen makes 2. So nitrogen amines, there's different kinds. There's NH and there's NH2, and there's actually trialkylamines, which is this guy. So this would be triethylamine because it has 3 ethyl groups on the nitrogen. Okay, this guy would be diethylamine. This guy is tert-butylamine. Okay. Isopropylamine. And finally, that is just ethylamine. All right, so these are the amine groups. All right, we've talked about the carbonyls again already. Okay, here I've included carboxylic acids in our blue circle because it doesn't overlap in this case. All right, there's actually 2 kinds of groups that contain a nitrogen that is bound to a carbonyl carbon. Okay, the one that we care the most about are amides. Another one that will probably come up in biochemistry, we're not going to talk too much about it in this class, is urea, which is shown here. This is a special case in which there isn't a carbon on the other side of the carbonyl, but there's a nitrogen on both sides of our carbonyl carbon. Okay, so hopefully this helps differentiate alcohols from acids, amines from amides. Okay, so I don't care how you get good at this, just, you know, if you find an OH group or you find an NH group, always ask yourself before you assign what it is it attached directly to a carbonyl or is it not? Okay, and hopefully that'll help you avoid common mistakes. All right, so very briefly, I went over this in lecture at the end of Gen Chem 2, but you know, I showed you these silhouettes. I said, you know, you folks can look at these structures and you can tell me where these people's hands are, right? All of these hands look very different from one another, right? Here we have upturned hands, here we have sort of sideways pointing hands, downward pointing hands. You know, all of these hands are in slightly different positions, but you guys would have no problems recognizing where the hands are in these silhouettes because you're used to recognizing hands. You recognize that they can take on different shapes, they can point different directions, it's not a problem. Okay, the same thing would be true in something like this, all right? Obviously, you guys don't look at geometric shapes as much as you look at people, but you can look at this, you could tell me how many ovals there are, how many squares there are, how many rectangles, how many diamonds, how many triangles, okay? It would get a little bit complex in this case because there are lots of different triangles to look at here, and so that could take some time. So things can get a little bit more complex when trying to recognize shapes in a structure like this, all right? But recognizing shapes in a structure like this is essentially the same exact thing as identifying functional groups or the pieces of a complex molecule.